Hi, welcome to the class. Today we will continue our discussion on the electric field due to an electric dipole. And today we are going to proceed with another derivation where we will be calculating electric field due to a dipole along equatorial line or broadside position. So before this we had done electric field along the axial line, which was coming to be 1 upon 4 pi epsilon naught 2p upon r cube, where I told you that this axial is inversely proportional to r cube. This is for dipole, and this is due to a single charge, and this electric field is inversely proportional to r square. Now I'll tell you what do we mean by this equatorial or broadside position first. So again I am telling you that whenever you do a derivation, make sure that you draw a label diagram and you do the introduction part properly. So this is a very important and necessary thing. So this is my diagram where I have drawn a dipole separated by a distance 2a. Now the center of the dipole is O. Let me name these points as A and B. Now guys, this equatorial point or equatorial line means from the center of the dipole you draw a perpendicular line up to a point P. So this point P is the point at which you have to calculate the electric field. So this point will become, this line will become equatorial line, and this point will become equatorial point, sometimes known as broadside position as well. Right? Now what I have done, where will be the electric field of this positive charge at point P? Will it be towards plus Q or will it be away from plus Q? Answer is it will be away from plus Q, which we have studied already. Where will be the direction of electric field due to minus Q? Will it be away or will it be towards? It will be towards, right? Now if I take these angles as theta and this as theta, so this angle being an exterior angle will be 2 theta, sum of two opposite interior angles. Exterior angle, property of a triangle, exterior angle is equal to the sum of two opposite interior angles. So that will be 2 theta. Now we know that this E1 is a vector, E2 is a vector, and they are inclined like this. They are inclined like this at an angle of 2 theta. So using the parallelogram law of vector, so two vectors are represented by the two adjacent sides of a parallelogram, then the resultant will be given by the diagonal. Resultant will be given by the diagonal. So resultant will be given by the diagonal. So this resultant will be given by this, and let me call this resultant as E. Alright. So this is the labeled diagram. Now you write an introduction part about it. Consider an electric dipole having charges plus Q minus Q separated by a distance 2a. Let us consider an equatorial line OP, and we have to calculate the electric field at P. Obviously, if this is 90, you can use Pythagoras theorem. This is A. Using Pythagoras theorem, this distance will be under root A square plus x square, and similarly this distance will be A square plus x square. So this is a label diagram. Please write introduction part about this derivation and then proceed. So I am going to proceed now. Electric field at P due to plus Q. What will be this electric field at P due to plus Q? It is E1. How much will be E1 using this formula? 1 upon 4 pi epsilon naught P upon R square. What is the distance of P from plus Q? It is under root A square plus x square, and then we have whole square. E1 is equals to 1 upon 4 pi epsilon naught P upon A square plus x square. This is equation number 1. Similarly, electric field at P due to minus Q. How much will it be? E2 is equals to 1 upon 4 pi epsilon naught P upon under root A square plus x square, again this. You should write the direction also here, like E1 it's away from AB. So I can write here the direction of this is away from AB and this is towards PB. It means it is coming like this. If you remove this square, E2 will be 1 upon 4 pi epsilon naught P upon A square plus X square. This is equation number 2. As you can see from 1 and 2, we got that these two are equal. From 1 and 2, E1 is equals to E2. Right? Now for this resultant, we will be using the formula for the resultant which is given by parallelogram law of vector. So the formula for resultant of two vectors is always given by r is equals to under the root a square plus b square plus 2ab cos theta. If I do it with e will be under the root e1 square plus e2 square plus 2 e1 e2 and the angle between e1 and e2. So what is the angle between e1 and e2? 2 theta. So it will be cos 2 theta. Now we know that e1 and e2 are equal. So instead of e2 I am writing e1. Okay? Because they are equal. So e is equals to under the root e1 square plus 2 e1 place of e2 I am writing e1 and then cos theta. If I solve this, I will get e is equals to under the root 2 e1 square plus e1 into e1 2 e1 square and then cos 2 theta. E is equals to under the root, I am taking 2 e1 square common, 1 plus cos 2 theta. Guys, 1 plus cos 2 theta is equals to 2 cos square theta. Okay? 1 plus cos 2 theta is equals to 2 cos square theta. E is equals to under the root 2 e1 square 2 cos square theta. E is equals to under the root 4 e1 square cos square theta. E is equals to 2 e1 cos theta. Square will remove this root. Now E is equals to 2 into 1 upon 4 pi epsilon naught q upon a square plus x square. And then in place of cos theta, let me just remove this part. In place of cos theta, you know that cos theta is equals to base upon hypotenuse. This is angle perpendicular. This is base and this is hypotenuse. So base upon hypotenuse. So base is A and hypotenuse is under the root a square plus x square. Right? Guys, what is it? 2 into q into a. This is P, electric dipole moment. 1 upon 4 pi epsilon naught P upon a square plus x square, and then I can write this as a square plus x square whole power 1 by 2 because root x can be written as x to the power half. A square plus x square whole power 1 multiplied by a square plus x square whole power half. Bases are same, their powers will be added up. 1 upon 4 pi epsilon naught P upon a square plus x square whole power 3 by 2. This is the expression for electric field along the equatorial line. But again, we will be using the same for a small dipole. So for a small dipole, if I use it for a smaller dipole, this x, which was the distance there, will be much greater than 2a, and in that case you can neglect this a square whole power 3 by 2. So I am just left with, this is E equatorial one upon 4 pi epsilon naught P upon, we will remove this a square whole power this, and then I am left with x square whole power 3 by 2. This goes off. So E equatorial is equals to 1 upon 4 pi epsilon naught and then P upon x cube. Now look at this expression. From this expression also we can see that electric field due to a dipole along the equatorial line is also inversely proportional to R cube. So this is another point which we could make out, and axial was also inversely proportional to R cube. If you take a ratio of these two, then if I take E axial upon E equatorial, you know that this will cancel this will cancel this, P will cancel this, and this ratio will be 2 by A. And if I write it in the form of ratio, it will be E axial E equatorial 2:1. So this will be the ratio for E axial and E equatorial. So this was all about the electric field due to the dipole, and dipole along axial line and dipole along equatorial line, right? So this is it in this class. In the next class I teach you one more derivation along with the questions. We'll also do the questions, right? Thank you.